Now let's talk about measures of variability. We have discussed about central tendency. So measures of variability is something that gives us, again, the purpose is same. I have 100 students. I have scores of the 100 students listed out, 10, 12 and so on up to 98. It's very difficult for me to understand the behavior of the class, right? Are the students of the class concentrated at a particular score? Let's say I can have something like this, okay, 100 students. All the 100 students can get 60, 60, 60. The average is still 60. The median is still 60. The mode is also still 60 for this case, right? I can have other case where the data would be like 1, 2, 3 and so on up to maybe we can start from 1, 2, 3, 60, let's say 90 or something. It has to be much more than that, but anyways, so the scores could be spread out in such a way that I can still have the average 60, median 60, mode 60, right? This is still possible. But see the difference, every student got 60, 60, 60. That means everyone is at the same place. Here I see dispersion of students getting very less as well as very high. This is like, distribution of students across the entire scale. So the behavior is different for the two groups, right? Here I understand that the students are equally good and they're scoring a decent score. Here the students, some of them are really good, some of them are really poor, and some of the students are doing okay, decent. So to understand this part, right, how well the data is dispersed, how wide it is, spread out, or how close all of them are, even though the central tendency could be same. That's why central tendency would not solve the problem which I'm posing here. So we use the variability, measures of variability. There are multiple ways: range, variance and standard deviation. So let's talk about how we calculate them. How to calculate range? Range is simple. In the given data set, range is calculated by doing maximum value minus minimum value, as simple as it is. So if I have a data set, doesn't matter how many data points it has, let's say 20, 40, 60, 30, 10, 90. And what is the range? Maximum is 90, minimum is 10, so it's 90 minus 10, 80 is the range. So this gives me a sense of how the data is dispersed, right? That's like the max minimum. I can have some other group which has like 60, 50, 30, 30, 60, 40. What is the range in that case? 60 minus 30 is 30, right? This data is relatively, if you see, all of them are relatively closer to each other than this. That's one example. It is a very rudimentary and crude way. The range is not the better solution to find the variability. But anyways, doesn't matter. You don't need to know beyond a point. Just find out how you calculate range. That's it. Then how do I calculate standard deviation? This is a bit complicated when I show in terms of formula. Let me take a simple data set. Let me say we have 2, 6, 7, 9 and 10. Okay. So let's take an example like this. Maybe I'll just change this to 3. Yeah, it makes sense. So what is the formula for standard deviation? There are multiple ways to find out standard deviation actually. Root square mean error is one of them, if you have ever heard this. So standard deviation is in a way errors, okay? We're talking about errors. We are expecting the data to behave in a certain manner. Whatever the dispersion or the deviation from the expected behavior is called the error, and we're calculating that. There's also something called absolute errors, right? Use absolute mods to calculate it. But anyways, what we use is only root mean square for the calculation. That's what the exams also test. Don't worry about rest of the things. The formula would look something like this. Summation of I is equals to 1 to n xi minus x bar square by n. So what is xi is each data element. So that's why x1, x2, x3, x4, x5, these are the 5 data points in this case. X bar is the average, the mean of the given data set, and n is the number of values, right? That is something that we know. So what should I ideally do? Don't worry about the formula even if you are not understanding it. First step, when I get data set, find the average. That's 3 plus 6 plus 7 plus 9 plus 10 by 5. 9, 16, 25, 35 by 5. 7 is my average. Right? Now what is the next step? You see this, the formula is basically pick each element, subtract it from the mean and square it. So 7 minus 3 or 3 minus 7, anything is fine. Plus 7 minus 6, the next element. Plus 7 minus 7. Plus 7 minus 9. Plus 7 minus 10. So what did I do? I subtracted average, or I subtracted each element from the average. 7 minus 3, 7 minus 6, 7 minus 7, 7 minus 9, 7 minus 10. I squared all of them. I added them by how many? 1, 2, 3, 4, 5 elements of 5, and then put a square root outside. That's how you find the standard deviation. As simple as it is. 7 minus 3 square is 4 square, 16. 7 minus 6 is 1 square is 1. 7 plus 7 minus 7 is 0 square is 0. 7 minus 9 is 2. Minus 2 square is 4. And minus 3 square is 9. This come out to be 17, 21 by 30 by 5 is square root 6. That's the standard deviation. Right? That's how you calculate the standard deviation. Bigger the value of standard deviation, more it says the data is away from, expected behavior. So ideally the expected behavior in this understanding is the average. All the data points, if I had a data set which is 7, 7, 7, 7 and 7, average would be 7, and this 7 minus 7 square, 7 minus 7, 7 minus 7, 7 minus 7 and 7 minus 7, all of them would give me 0, 0, 0 by 5, and that will be 0. In this case, the standard deviation is going to be 0, right? So that's expected, but I am seeing the data being a bit far away from it. I can have another data set like this, let's say 6, 7, 7, 7 and 8. The average is still going to be 7 for this. The standard deviation of the data set C will be definitely greater than the standard deviation of B, and standard deviation of A would definitely be greater than C. Why? Because you see the data 3, 6, 9, 10 are far away from the average 7. The average 7, not this 7, I'm saying about this average. Whereas here, most of them are same as 7. These two are also pretty close to 7 compared to this, right? 3 and 10, etc. So that's why obviously even without calculation, I can say, let's say I have another data set like D, which has points like 1, 2, 7, right? And then something like, what will give me, let's take another example like 7. So here I see 5 and 6 missing, right? 11 plus 18. So yeah. This will also give me same answer for my average being 7, but the standard deviation will be very far, because from 7, 18 is very far off and this value is also far off. So I will automatically get standard deviation of D greater than this. So I'm saying that you may not necessarily need to find out standard deviation always to compare sometimes. So you can be smart in understanding this. If you understand the purpose of calculating standard deviation is understanding how much the data is dispersed or deviating from the average or expected. So as simple as it. So if the data points are pretty close to each other, the standard deviation will be very much, close to 0. Far away from each other or from the average in a way, they will definitely have a higher standard deviation. That's a conceptual understanding that would help you solve problems faster and better. Variance is nothing but simply square of standard deviation, right? As simple as it. In the earlier case, the standard deviation was root 6. So if I do square of it, 6 is my answer. That's variance. If you get to see question, what is the variance of a given data set? Find the standard deviation as it is, square it. So if you see the standard deviation as square root, so either you can, I can remove the formula and say that is my variance if I have to write as a formula. Whatever it is, just simply do the differences from the average, square them, add them, and by the number of values. You don't have to put the square root when it is for the variance. Or you find the standard deviation, square it at the same thing, right?